move.
Sorry, didn't mean to interrupt you. Go ahead. What'd you do?
No, you're okay. But I moved the 25/4 outside of the parentheses along with that 2 in the front, which I multiplied by that 25/4.
Good. So leave the positive 1 inside. And we're going to kick out the negative 25/4 times negative 2 minus 7. Okay, you have to remember that that's not just minus 25/4, it's being multiplied by the negative 2. And then this is something squared. And what it is it's the square root of that 25/4. So it's going to be 5 halves. Okay, 5 halves. And you can see if you multiply that out, x minus 5 halves times x minus 5 halves, you will get that quadratic. And then we're going to add, this is going to be, it's 50/4. I'm just going to, when you multiply straight across, but that also is 25 halves. So this right here is actually going to simplify to positive 25 halves minus 7. And, ooh, okay, so we have to do some more fraction work here. That's what makes this tedious, this one. So 25 halves minus 7 is 25 halves minus, if I multiply by 2/2, that's 14 halves, which, yes, Madison, very good, is going to be 14, actually 11 halves, because that's going to be 5 minus 4 is 11, 2 minus 1 is 11, it's 11 halves. So this ends up being negative 2 times x minus 5 halves squared plus 11 halves. So my vertex is 5 halves, comma 11 halves. What did I say? Oh. that little arithmetic will catch you up, man. Every time. I mean, you guys see I make mistakes all the time. They keep calling me about my health insurance. I am like, but they're trying to get me to join stuff I don't want to join. Leave me alone. All right, so now let's do intercepts. Okay, so the x-intercepts, I'm going to take the original problem, which is negative 2x squared plus 10x minus 7, and set it equal to 0. But I will tell you right now that this does not factor. We have to use quadratic formula. So I picked this so we could review a bunch of stuff, to be honest. Would I make this a test question? Unlikely. There's a lot of parts to it, a lot of moving parts here. All right, so x is negative 10. I'm going to take negative b plus or minus b squared is 100 minus 4 times a times c all over 2 times a. Not nice. So negative 10 plus or minus 100. That's 8 times 7, which is 56. 3 negatives makes it negative still, over negative 4. So negative 10 plus or minus, what's 100 minus 56? 44? Yeah, that makes sense. Over negative 4. So that means x is negative 10 plus or minus. Now this is 4 times 11. So it's going to be 2 root 11 over negative 4. And to completely simplify this, you could factor a 2 out of the top, and that's negative 5 plus or minus square root of 11 over 2 times negative 2. So x is negative 5 plus square root of 11 over negative 2. That's one of the roots. And that's one of the intercepts. And negative 5 minus square root of 11 over negative 2. And weirdly enough, the top one is probably going to be something negative and the bottom one positive, but I don't know. We'll see. Let me move this further down. Okay. All right, now y-intercept is much easier. We're just gonna plug in 0. So you get 0 minus 7. So f of 0, let me put it this way. F of 0 is gonna be 0 plus 0 minus 7, which is just negative 7. So that's 0 comma negative 7. All right, so here's the deal. How do we graph this? A lot of ugly points here. Well, let's see. Put it over here, I have a little more space. 0, negative 7. So let's put that on here. 1, 2, 3, 4, 5, 6, 7. There's the y-intercept. This is really 2.5, comma, 2 goes in there, 5.5, right? So 1, 2, 1, 2, 3, 4, 5, 2.5, about right here. So this is 5 halves, 11 halves. And you can kind of see that, you know that your x-intercepts are not nice numbers. So I'm just gonna, I'm gonna draw this. I mean, if we did an approximation here, this is approximately square root of 11 is about 3.2 because square root of 9 is 3. So this is approximately negative 5 plus 3.2 over negative 2. So that's going to be something negative over negative.
I think it's negative 1.8 over negative 2.
So it's just under 1. It's about 1. So it is going to cross like about here. And the other one is going to be negative 5 minus 3.2 over negative 2, which is about negative 8.2 over 2. So it's about 4.1. So yeah, that looks pretty symmetrical. So your parabola is going to look like this. That's a lot. Okay. I just wanted to go through the process so you could remember it, but I would pick it so the x-intercepts were not so ugly. But you get the idea. Any questions there? Oh, that's a lot. I might not do that problem next hour. All right. For this one, this is the nonlinear inequality. Okay. So first you have to get everything on one side. And then get one fraction. So 4x over x minus 1. I'm going to multiply this by x minus 1 over x minus 1. And then this is 4x minus 3 times x minus 1 over x minus 1. And you should have gotten 4x minus 3x is going to be x, and then this is going to be plus 3 over x minus 1. Did you guys get this? Anybody else? Probably we're still doing number 1, huh? Okay, so remember, you cannot multiply by an unknown across the inequality. We cannot solve this unless we do a sign chart. So my sign chart, okay, has two things, zeros. So when this thing equals 0, which is going to be when x plus 3 equals 0, if you multiply both sides by x minus 1, you get x equals negative 3. And then you also have to look for your bad numbers. So that's going to be when the denominator is 0. So x minus 1 cannot equal 0. X cannot equal 1. Okay. So negative 3, 1. This is bad. This is 0. This is included because of the equals, and this one is not. And I am going through this fast because it's review, but also because I got to get to the other stuff today. But I will ask, is there any questions so far? Now, the next thing you do is you check sections, okay? We check regions, 1, 2, 3. And I'm going to plug it in. So I'm going to use this x plus 3 over x minus 1. So if I put in -4 plus 3 over -4 minus 1 is -1 over -5. So this is going to come out positive because it's negative over negative. Okay. Second region, let's pick 0. 0 plus 3 over 0 minus 1 is -3. So that's negative. Okay, third region, I'm going to pick 2. So 0 plus 2, excuse me, not 0. I'm going to pick 2. So 2 plus 3, where 2 minus 1 is 5 over 1, which is positive. So we get positive, negative, positive. Go back to your question here. It's saying, when is this going to be less than 0? So it's the middle. It's going to be this part right here because it's less than, okay? And so my answer is going to be -3 included to 1 not included.
So to do a sign chart, you get all your bads and all your zeros, and then you take whatever equals 0 and you plug it in to see what's positive and what's negative.
Not what's equal to 0. You pick numbers in between there.
I mean, well, yeah.
Yeah. Okay.
Okay.
Okay. Just in my shirt, because if you plug in -3, you're gonna get 0. That tells you nothing. Okay. All right. Any questions? Okay. All right. So let's go back to 11.4. I asked Omar to do some problems with you in workshop yesterday. Did you guys do that? Did you do any conversions?
Yeah, we did.
Okay, so let's talk about it some more. So what I was saying yesterday is that the angle that is 180 degrees, when we put it on your unit circle, that angle is pi, okay? So the conversion unit that you need to remember is that 180 degrees equals pi radians, okay? So let's do some examples of just converting, and I'll show you how I do it. I'm hoping he does it the same way. He did it the same way. Some people may have other methods. This is one of those things that if your method works and you're getting it right, then yes, by all means, please use it. But if you're not getting it right, then you need to follow along what I'm doing, okay? All right, so here's example 1. Convert 60 degrees to radians. Okay. Make sure I do all the good examples. Okay. So what I'm going to do is, I thought I had different notes. I'm going to take the 60 degrees, and to convert it, I'm going to multiply I'm sorry, hold on. I'm going to take 60. Okay, so 60 degrees is the same as 60 times 1 degree. Okay, do you guys see that? If I take 1 degree and multiply by 60, I get 60 degrees, right? So what we're going to do is we're going to substitute in for that 1 degree. One degree equals, now what do I substitute in? Okay, I'm going to take my 180 degrees equal to pi radians. And I want to be able to use the conversion where I substitute in something for 1 degree. So I have to get 1 degree over here. Okay, so this right here, 180 divided by 180 is 1 degree. 1 degree is equal to pi over 180. So when I convert this, I'm going to take 60 times this that I just got, pi over 180, to get to radians. Okay. So I want to convert, I have to figure out how many radians is equivalent to 1 degree. Well, it's pi over 180. Okay. Then when we multiply straight across, this is just 60 pi over 180, which simplifies as 60 times pi over 80. 180 is 60 times 3. Okay, right? Because 3 times 6 is 18. This is a 1. And we get pi over 3. Any questions? Yeah. 1 radian equal, yes. We're going to convert back and forth this way. All right, here's example 2. I want to convert 2 radians to degrees. Okay. So 2 radians is the same as 2 times 1 radian. Okay. So let's go off to the side. I'm going to use my conversion. This is what I know. I know that 180 degrees is pi radians, but I need 1 radian. So I'm going to divide both sides by pi. And I now know that 1 radian, because pi over pi is 1, that's 180 over pi. Okay. Now, some people memorize this. Like, oh, they just know 1 radian is this and 1 degree is this. That's fine. But as long as you know 180 degrees equals pi radians, you can always get where you need to be. You can always just figure it out this way. Okay. So I'm going to come back over here and do 2 times, and now I'm going to substitute in, instead of 1 radian, I'm going to put in 180 over pi. Okay. And this is degrees, by the way. So this is going to be 2 times 180 is 360 degrees over pi. Now here's a huge misconception. Pi is not just specific to radians. Pi is just a number. Okay, so all this is a measure of degrees. It's not an even number. It's about, if you did 360 divided by about 3, that's about 120. Okay, so you guys see this? So pi does not always mean radians. Pi is just a number. Approximately 3.14. So you cannot just say, if something has pi in it, you cannot assume that it's just radians. That's not true. Okay. All right, let's do another one. Example 3. I'm going to pick one from a final exam. This is a final exam type question. Let's convert. Oh, here's a couple of good ones. Convert, here's a negative 30 pi degrees to radians. And B is going to be convert 4 pi over 9 radians to degrees. Okay, so I'm going to do these 2 examples. Yes, if you can remember that, Marianne, that's right. Okay, so first, I'm going to write this as negative 30 pi times 1 degree, because that's my unit. Okay, my unit is in degrees. Now I need to figure out what is 1 degree. All right, well, let's go over here and do it. 180 equals pi radians. I need 1 degree, so I'm going to divide by what? Am I going to divide by 180 or am I going to divide by pi?
180.
180. So this is 180. So 1 degree is pi over 180. So I'm going to multiply here by that. All right, so, or weird, because we end up getting negative 30 pi squared over 180. And then the only other thing I have to do is figure out what 30 over 180 is. And that's 30 times 1, and then 180 is 30 times 6. So this actually is negative pi squared over 6. We went into radians. I want to include the unit. Any questions? Okay. Now the second one over here, I have 4 pi over 9, and that's times 1 radian. Okay. So 1 radian, let's see. So now I have 180 equals pi radians. To get 1 radian, I divide by pi. So 180 over pi equals 1 radian. So this is 4 pi over 9 times 1 radian is 180 over pi. Any questions? All right, then it's just simplifying, right? So this is, the pi's are going to cancel. That's a 1. And actually 180 over 9, so this is 4 times 180 over 9. But 180 is 9 times 20. So this is 4 times 9 times 1, or I'm sorry, times 20 over 9. And we end up getting 80 degrees. Any questions? Notice that in the first one, pi does not cancel. It's pi times pi, that's pi squared. You have to have that. And then in the second one, because it's in the top and bottom, we get a form of 1, and it does simplify out. Okay? You guys feel okay with this? All right. Our very last section of the semester is 11.5. I don't know. I'll tell you what, I think that's one thing I like about school. There's this sense of like completion every semester. When you get a job in real life, and you just work, I don't know. I like the beginning and end of stuff. I like that feeling. All right. All right, so 11.5 is right triangle trigonometry. Okay. And again, where this comes from, it does come from the unit circle. Okay. So for example, we haven't talked about any other points on the unit circle, but there are some famous ones. So if you cut this first arc here into 3 parts, remember this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. But if I stop here, if I cut this first part in half, or this, if I take pi over 2 and I cut it into thirds, do you guys see how that arc is like 3 equal pieces? Each little rounded piece is about equivalent. Well, I cut it into thirds, and what I get is pi over 6. So, and this is what you will have to know in 1800, but I just want to kind of connect the dots for you for a minute. That's pi over 6. That's pi over 6. And if I do another, this is 2 pi over 6, which simplifies to pi over 3. So there are other famous stops on this unit circle. We're just not going to deal with these too much. But what I do want to point out is this. This point here, I will tell you the coordinates are square root of 3 over 2 and 1/2. Okay? Those are not like nice looking points. They're not nearly as nice as like, oh, this is just 0, 1, okay? Not as nice, but how do we get those? Well, the x coordinate, if I drop down to this x-axis here, that vertical distance is my x coordinate. Okay? That's how we get it. We don't think about it too much, but that's the vertical distance. And then the, I'm sorry. What I just said was completely incorrect. The vertical distance is really a measure of which coordinate. Let me start over. Just rewind what I just said. Like, blah, blah, blah. Okay, to get to this point on my unit circle, I have to travel a horizontal distance and then a vertical distance, okay? A horizontal distance and a vertical distance. And when we label that point, the horizontal distance is x. That's going, you go right to get to your x value. And then to get to your y value, you go up. This is y, okay? Notice that this makes a right angle. And if I put the radius on there, I get a right triangle, okay? So what we're gonna do, so the right triangle is related to the unit circle. You can put these right triangles on the unit circle, but I'm just gonna peel it off. We're gonna dump the unit circle for a while and just look at these right triangles. So if I look at this right triangle, this distance here, if I just pick this one up from the unit circle and just move it off, the x value is square root of 3 over 2, that distance. The y value is 1/2. What's my hypotenuse? What's the length of the hypotenuse? Anybody know it? If you're not sure, we can get it. What theorem would we use?
Pythagorean theorem.
That's right. So let's take these and square them and add them. So this is 1/4. Squaring square root of 3 is just 3 over 4. What's 1/4 and 3/4? 4/4, which is 1. My hypotenuse is 1, but that should not have been a surprise because what is special about the unit circle?
Its radius is equal to 1.
That's right. Okay. So you guys see how this is all related together, right? Okay. So now that I've shown that, let's just deal with right triangle stuff. Any questions about that? So we could do this. You could do this just to be clear. There's also another really nice right triangle we could work with. Okay. Same principle. Radius is 1. The y value here is actually square root of 3 over 2. These reverse, okay? That's more work for you to do in 1800. All right. So let's just look at the right triangle. And these are right triangles that don't necessarily have to be on unit circles, but just a reminder that if I have this angle here, I'm going to call this angle theta. Okay. The way we label the sides of this triangle is this is the hypotenuse because it's always across from the right angle. okay? Now the side that is directly across from theta is this side, and this is just called the opposite side of the triangle from theta. Okay, so in terms of orientation, that is opposite side. Now the side that is right next to theta, meaning it shares one of its rays is part of theta. Okay, this is called adjacent. Okay. And our trig functions can be related to this. So if I look at sine of theta, that's going to be opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And then tangent of theta is opposite over adjacent. I almost said the wrong thing. Yeah, so I don't know the song. Do you want to sing it for us, Madison?
No.
Okay, so if SOHCAHTOA helps you, that's fine. So here's S-O-A. That's so C-A-H, A over H. SOHCAHTOA, SOHCAHTOA. So that's a little mnemonic device that students can use to remember that its sine is opposite over hypotenuse, cosine is adjacent over, you see I don't use it, adjacent over hypotenuse, and then tangent is opposite over adjacent. Okay, so if that helps you keep it straight, by all means use it. Okay. Any questions about those rules and definitions? All right, so let's do an example. Find the cosine, sine, and tangent of alpha. Okay. So here's my angle alpha. The hypotenuse is 5, this is 4, and this is 3. Okay. So we'll start with cosine. Cosine of alpha is adjacent over hypotenuse. So what side is adjacent? What's the length of the adjacent side?
3.
Yeah, good. It's 3 over my hypotenuse is 5. Now sine of alpha is opposite over hypotenuse.
4 over 5.
4 over 5. And then tangent of alpha is opposite over adjacent.
4 over 3.
4 over 3. Now, here's the thing you need to realize. Everything depends on which angle you're talking about. If I now want to know same things for, do the same for beta. We'll call this angle beta. Okay. Now the orientation of my sides change. So cosine of beta, that adjacent is no longer 3. This is the adjacent side for beta. So this is going to be 4 over 5. Sine of beta, that opposite now is 3. That's 3 over 5. And then tangent of beta is going to be opposite as 3 over 4. So depending on what angle of the triangle you're talking about, opposite and adjacent can switch. Does that make sense? Are there any questions about that? It's all about the orientation of your angle as to who is opposite and adjacent, right? Yeah, let's do this one. All right, here's an example. Example 2. Find the value of x and the values of cosine of angle A, sine of angle A, and then tangent of angle A. Okay, so here's my triangle. This is 7, 3, and x. Okay, and the angles, oh, I gotta tell you who's who. This is A, B, C. Okay, if I don't label my angles, you don't know who's opposite and who's adjacent. You gotta know who we're talking about, right? So angle A, here's angle A right here. That's what we're talking about. So let's first just set up our trig functions. So what is, how about, let me call on Jack. What would you say sine of angle A is? And you can use x for right now. What is sine of angle A?
Is it 3/7?
Well, sine
Oh.
is opposite.
Oh yeah. X/7.
There you go. And then cosine of angle A then is what? Go ahead, Jack. What's cosine? You might as well do all these.
It's X/3. Oh wait, no. 3/7.
Yeah. So if it helps, take a minute and realize this is adjacent, okay? And then this one over here, this is opposite. Okay. All right, and then what's tangent?
That's X/3.
Yeah. So very good. Now the problem is we still have to find x. Can we find it? Yeah, we can. What do we use to find that?
Pythagorean theorem.
Yeah, so we must find x. So we're going to do x squared plus 3 squared equals 7 squared, which is x squared plus 9 equals 49 minus 9, and x squared equals 40. Did I? Yeah. Now, x is square root of 40. And we are going to simplify that. So this is square root of 4 times 10.
2 square root 10.
There you go. So it's not always going to come out perfect, but that's okay. So now I want to go back and fill in that information. So sine is not x/7. It's 2 root 10/7. Okay. Cosine is good. We lucked out there. And then tangent is 2 root 10/3. Okay, any questions? All right, let me know how you're feeling about this stuff, this trig stuff. Thumbs up or oh no. Give me some sense of how this is for you. Okay. All right, Madison loves trig, I forgot. Okay, you guys, I think this is enough for today. We'll stop here. I have office hours at 11:30 if you would like to come. Okay. All right. Bye-bye.